Preparing for a LLM Engineer interview questions interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each one, you'll see what the interviewer is testing, the core concepts you should cover, and a sample answer. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Can you explain how the transformer architecture works and why it is effective for LLMs? The interviewer wants to assess your understanding of the core architecture behind modern LLMs, including attention, embeddings, positional encoding, decoder-only design, and next token prediction. While answering, focus on self-attention, token embeddings, positional information, feed-forward layers, causal masking, and why transformers scale better than recurrent architectures for language modeling. A transformer is a neural architecture built around attention rather than recurrence. I'd explain that token embeddings are combined with positional information, then passed through stacked attention and feed-forward layers. Self-attention lets each token weigh other tokens in the context, which is why the model captures long-range dependencies. In decoder-only LLMs, causal masking prevents looking ahead, making the architecture suitable for next token prediction and generation tasks. Question 2. What is the difference between pre-training, fine-tuning, and instruction tuning? The interviewer is testing your understanding of the LLM lifecycle, from large-scale unsupervised learning to task adaptation and alignment for user-facing instruction-following behavior. Make sure to cover training objectives, data types, compute intensity, downstream adaptation, supervised instruction datasets, and how instruction tuning changes model behavior without teaching all knowledge from scratch. Pre-training teaches the model broad language and world patterns, usually through next token prediction on massive corpora. Fine-tuning adapts that pre-trained model to a narrower task or domain, such as legal summarization or code generation. Instruction tuning is a supervised fine-tuning step using prompt response examples, so the model learns to follow user intent more reliably. I'd separate knowledge acquisition from behavior shaping because that distinction matters in production. Question 3. When would you use RAG instead of fine-tuning an LLM? This question evaluates whether you can choose the right LLM adaptation strategy based on freshness of data, cost, latency, accuracy requirements, and operational complexity. In your answer, talk about external knowledge, frequently changing data, source attribution, private documents, fine-tuning for behavior, and combining RAG with tuning when both knowledge and style matter. I use RAG when the model needs access to current, private, or source-specific information that should not be baked into weights. For example, if a support bot must answer from updated policy documents, retrieval is safer and cheaper than repeated fine-tuning. Fine-tuning is better when I need consistent format, tone, or task behavior. In practice, I often pair RAG for knowledge with light tuning or prompting for response quality. Question 4. How would you design a retrieval-augmented generation pipeline for an enterprise knowledge assistant? The interviewer wants to assess your ability to design an end-to-end RAG system, including ingestion, chunking, embeddings, retrieval, ranking, context construction, and answer generation. Be sure to mention document parsing, chunking strategy, metadata, embedding models, vector search, hybrid retrieval, re-ranking, prompt assembly, citations, access controls, evaluation, and monitoring. I'd start with document ingestion, clean parsing, and chunking that respects headings, tables, and semantic boundaries. Each chunk would get embeddings plus metadata such as source, owner, timestamp, and permissions. At query time, I'd use hybrid retrieval, re-rank the candidates, then build a compact prompt with citations. The generator should answer only from retrieved context when required. I'd evaluate retrieval recall, answer faithfulness, latency, and permission leakage. Question 5. What causes hallucinations in LLMs, and how would you reduce them in a production application? The interviewer is testing your understanding of probabilistic generation, knowledge gaps, prompt ambiguity, retrieval failures, and practical guardrails for improving factual reliability. While answering, focus on model uncertainty, missing context, poor retrieval, constrained prompts, citations, abstention behavior, validation checks, tool use, human review, and evaluation with factuality metrics. Hallucinations happen because the model generates plausible tokens, not verified truth. They increase when context is missing. The prompt asks leading questions. Retrieval returns weak evidence, or the model is forced to answer. I reduce them by grounding responses in retrieved sources, requiring citations, adding abstention rules, validating outputs with tools or schemas, and testing against adversarial examples. For high-risk workflows, I'd add human review or deterministic business rule checks. Question 6. How do tokenization and context windows affect LLM application design? This question evaluates your practical understanding of how text is represented, priced, truncated, and processed inside LLM systems, especially for long context applications. Make sure to cover subword tokens, token limits, cost, latency, truncation risk, chunk sizing, prompt budgeting, conversation memory, and why characters or words do not map perfectly to tokens. Tokenization determines how text becomes model inputs, and the context window limits how many tokens the model can consider at once. That affects cost, latency, and accuracy. If I pass too much conversation history or large documents, important details may be truncated or diluted. I usually budget tokens across system instructions, retrieved context, user input, and output. Good chunking and summarization become design decisions. Question 7. Explain LoRA or QLoRA and why parameter-efficient fine-tuning is useful. The interviewer wants to assess your knowledge of efficient model adaptation, GPU memory constraints, low-rank updates, quantization, and trade-offs versus full fine-tuning. In your answer, talk about freezing base weights, training adapter matrices, reducing memory requirements, QLoRA quantization, deployment considerations, and when full fine-tuning may still be preferable. LoRA freezes the base model and trains small low-rank adapter matrices inside selected layers. That makes fine-tuning far cheaper because I update a tiny fraction of parameters while preserving most pre-trained capability. QLoRA goes further by quantizing the base model, often to 4-bit, to reduce memory. I'd use it for domain adaptation or instruction tuning on limited hardware, while full fine-tuning remains useful for very deep behavioral changes. Question 8. How would you evaluate an LLM system beyond simply checking whether the output sounds good? This question evaluates your ability to define rigorous evaluation criteria, build test sets, measure task performance, and monitor production behavior over time. Be sure to mention golden datasets, human evaluation, task-specific metrics, retrieval metrics, factuality, safety, latency, cost, regression testing, A/B testing, and monitoring for drift. I'd evaluate at multiple layers. For retrieval, I'd measure recall, precision, and whether the right source appears in top results. For generation, I'd score factuality, completeness, format adherence, safety, and user usefulness using golden examples and human review. I'd also track latency, token cost, refusal quality, and regressions after model or prompt changes. A good evaluation suite should catch failures before users do. Question 9. How would you reduce latency and cost for a high-traffic LLM application? The interviewer is testing your production engineering judgment around inference optimization, caching, model selection, batching, prompt efficiency, and cost-performance trade-offs. While answering, focus on smaller models, prompt compression, caching, streaming, batching, quantization, routing by complexity, retrieval optimization, output length controls, and measuring cost per successful task. I'd first measure where latency comes from: retrieval, re-ranking, model inference, or downstream tools. Then I'd reduce prompt size, cap output length, cache repeated results, and route simple requests to smaller models. For self-hosted models, batching, quantization, and optimized serving engines matter. Streaming improves perceived latency, even when total time is similar. The key is optimizing cost per correct answer, not just raw milliseconds. Question 10. What are embeddings, and how do you choose an embedding model for semantic search? The interviewer wants to assess your understanding of vector representations, similarity search, domain fit, dimensionality, multilingual needs, evaluation methodology, and retrieval quality. Make sure to cover dense vectors, semantic similarity, cosine or dot product search, domain-specific benchmarks, multilingual or code requirements, chunking compatibility, cost, latency, and embedding refresh strategy. Embeddings are numeric vectors that represent semantic meaning, so similar concepts land close together in vector space. When choosing a model, I test it on real queries and documents, not just public benchmarks. I care about retrieval recall, domain vocabulary, multilingual needs, dimensionality, latency, and cost. For enterprise search, I'd also check how it handles short queries, tables, acronyms, and whether re-embedding is manageable when documents change. Question 11. How do function calling and tool use change the design of an LLM application? This question evaluates your understanding of connecting probabilistic language models to deterministic systems, including APIs, schemas, tool routing, error handling, and validation. In your answer, talk about structured outputs, JSON schemas, tool selection, execution boundaries, retries, permission checks, validation, observability, and why tools reduce hallucination for factual or transactional tasks. Function calling lets the model decide when to invoke tools, but the actual execution stays deterministic. I define strict schemas, validate arguments, enforce permissions, and handle tool errors explicitly. For example, a travel assistant should call an availability API instead of inventing flight options. Tool use improves reliability when the answer depends on current data or transactions. The design challenge is keeping the model helpful without giving it uncontrolled authority. Question 12. How would you handle prompt injection attacks in a RAG or agentic system? The interviewer is testing your awareness of LLM security risks, especially malicious instructions embedded in retrieved content, user inputs, or tool outputs. Be sure to mention instruction hierarchy, untrusted content separation, tool permissioning, output validation, allow lists, least privilege, retrieval filtering, logging, red team testing, and not relying solely on prompts. Prompt injection happens when untrusted text tries to override system instructions or manipulate tool behavior. I'd separate trusted instructions from retrieved content, label sources clearly, and tell the model that documents are data, not commands. More importantly, I'd enforce security outside the model through tool allow lists, permission checks, schema validation, and least privilege access. I'd also log suspicious patterns and run red team tests against the full workflow. Question 13. What is the difference between RLHF and DPO, and why are they used? The interviewer wants to assess your understanding of model alignment techniques, preference data, reward modeling, policy optimization, and newer direct preference optimization approaches. While answering, focus on human preference comparisons, reward models, reinforcement learning complexity, DPO simplicity, aligning helpfulness and safety, and how these methods affect model behavior rather than factual knowledge. RLHF uses human preference data to train a reward model, then optimizes the language model to produce responses that score well under that reward. It can improve helpfulness, tone, and safety, but it is operationally complex. DPO uses preference pairs more directly, avoiding a separate reward model and RL loop. I'd describe both as alignment methods. They shape how the model responds, rather than simply adding new domain facts. Question 14. How would you debug an LLM feature that started producing worse answers after a model upgrade? This question evaluates your production debugging process, including regression analysis, prompt sensitivity, retrieval changes, evaluation datasets, observability, and rollback strategy. Make sure to cover baseline comparisons, reproducible examples, prompt and parameter changes, retrieval diagnostics, golden test sets, logs, user segmentation, safety changes, and controlled rollout or rollback. I'd start by isolating what changed: model version, prompt, retrieval index, decoding parameters, or upstream data. Then I'd replay a golden test set against old and new versions, comparing failures by category. If RAG is involved, I'd inspect retrieved chunks before blaming the model. I'd check logs for specific user segments and edge cases. If impact is material, I'd roll back or route only low-risk traffic while fixing it. Question 15. Design a production LLM chatbot for a regulated financial services company. What are the key components and controls? The interviewer wants to assess your system design ability for a high-stakes domain, including reliability, compliance, data privacy, auditability, and controlled user experience. In your answer, talk about secure data ingestion, RAG, access controls, PII handling, audit logs, human escalation, refusal policies, monitoring, evaluation, model governance, and explainable citations. For a regulated finance chatbot, I'd design around control first, not novelty. The system would use permission-aware RAG over approved documents, with PII redaction, encryption, audit logs, and source citations. Prompts should enforce scope limits and escalation rules for advice-sensitive topics. I'd add output validation, safety filters, monitoring, and human review for high-risk cases. Model changes would go through evaluation, approval, and versioned rollback procedures. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.